Good morning to you, Senior 2. You are most welcome to this lesson. This lesson, I'm not going to teach any new thing. I'm going to take you through this topic which we just concluded about sorts. So I request you to pay maximum attention as we go through. And towards the end, I will do for you corrections of the previous assignment that I gave you. So let us revise this topic together. Feel free to ask a question even when I'm still teaching. If something is not clear to you, ask a question. So when we started this topic, we began with the definition of a solid. We said a solid is a compound. If you could get some revision book there and write some important points. For example, definition of a solid, that one is important. It is a compound formed when either or part of the ionizable hydrogen of the acid is replaced by metallic ion or ammonium ion. The key important thing there, I'm again saying, the hydrogen of the acid. You see, every acid starts with hydrogen. Every acid, it's in its formula, it starts with hydrogen. As we shall see later on when we begin a topic called acids and bases, we shall look at acids in details. But for now, you know that every acid starts with a hydrogen. So the definition of a solid, it is a compound formed when either all or part of the ionizable hydrogen of the acid is replaced by a metal or ammonium ion. That is the definition of a solid. Now, after knowing what a solid is, we looked at these examples. We said if, for example, the acid is hydrochloric acid, then the solid formed will be a chloride. The solid formed from hydrochloric acid will be a chloride. So, for example, if the salt is hydrochloric acid, and we can form sodium chloride as a salt. If the salt is sulfuric acid, and the ion that is going to replace hydrogen is ammonium, then the salt will be ammonium. The salt will be ammonium sulfate. If we have this as carbonic acid, this is carbonic acid. So the solid formed will be a carbonate or hydrogen carbonate. So if calcium replaces part of the hydrogen, if calcium replaces one hydrogen, then the solid formed is going to be calcium hydrogen carbonate. So that one is very simple. All these are solids. However, within these solids, you realize we have normal solids and we also have acid solids. So let us first remind ourselves of the definition of a normal solid. What is a normal solid? We agreed for a normal solid, for example, if I am to take this as the acid, for a normal solid, all the hydrogens of the acid are replaced. All the hydrogens of the acid are replaced. So, and the other thing that is important, we said monobasic acids. Monobasic acids, those are acids that contain one hydrogen atom. So all monobasic acids form normal solids. For example, hydrochloric acid, it has only one hydrogen. So that means if a metal ion or ammonium comes, it will replace all the hydrogen because it is only one. So there is nothing that remains when this hydrogen is replaced. So acids which have only one hydrogen atoms, for them they form only normal salts. Acid salts are formed by acids which have more than one hydrogen. For example, sulfuric acid. A metal can only replace one hydrogen. Let's say sodium can only replace one hydrogen, and the other hydrogen will remain, and you will form sodium hydrogen sulfate. So let us remind ourselves of the definition of normal salt. Normal salt, we said, it is a type of a salt where all the ionizable hydrogen of the acid is replaced by the metallic or ammonium ion. That is an acid salt. It is where all the ionizable hydrogen, all hydrogen, is replaced by the metallic or ammonium ion. We are again saying these salts do not contain ionizable hydrogen. Why do they not contain ionizable hydrogen? Because all the hydrogen has been replaced. Usually when we ask for the definition of normal salt, we continue to ask you the examples. And that shouldn't be a problem. You can put here sodium, it becomes sodium chloride. You can put magnesium, it becomes magnesium chloride. Here on nitric acid, you can put ammonium, it becomes ammonium nitrate. So all those are normal salts. For example, sodium chloride, meaning sodium replaced hydrogen of hydrochloric acid. Ammonium nitrate, meaning ammonium ion replaced hydrogen of nitric acid. Magnesium sulfate, meaning magnesium replaced hydrogen of sulfuric acid, like that. I think that one is not a problem to you. For acid salts, let's now look at acid salts. For acid salts, acid salts, we agreed they are salts formed when only part of the ionizable hydrogen of the acid is replaced by ammonium or metallic ion. It is formed when only part of the hydrogen, that means the metal or ammonium ion, does not replace all or part of the hydrogen ion. For example, we have sodium hydrogen sulfate. What does that mean? It means in our formula for sulfuric acid, sodium has only replaced one hydrogen, and the other hydrogen remains, and that's how we form sodium hydrogen sulfate. Potassium hydrogen carbonate, it means that potassium has replaced only one hydrogen of carbonic acid. Now, many of you have a challenge writing the formula of these compounds. Please, I told you when you were in senior 1 that you are not going to avoid the formula of these compounds. So kindly, I beg you people, please take time and learn the formula of these compounds. Know that the valence of sulfate is 2. Know that the valence of carbonate radical is 2. Know that the valence of chloride is 1. Valence of nitrate is 1. Then also learn the valences of the other compound, of the other metals, of calcium, magnesium, sodium, aluminium. You'll find your life simple. That will simplify your life. So we only paid attention to these acid salts, normal salts, but we said we also have basic salts, although these ones we rarely give them attention. These ones, no, let us not give them our attention. So we continued there, and we looked at more examples of how we can name salts. For example, if we have a metal as sodium and this is chloride, it means this chloride comes from the acid of hydrochloric acid. Sulfate comes from sulfuric acid. Nitrate comes from nitric acid. And carbonate comes from carbonic acid. So sodium, the salt formed is sodium chloride. Aluminium, and if this is if the acid was sulfuric acid, the salt formed is aluminium sulfate. Ammonium, and the acid is nitric acid, so the salt formed is ammonium nitrate. Potassium and carbonic acid, the salt formed is potassium carbonate. We looked at the most important thing. Even now, I'm still saying this is the most important part of chemistry. If you don't know this, then you don't know chemistry. If you don't know the solubility rules, your chemistry is very shallow. If you don't know the solubility rules, your chemistry is very shallow. Amera, do you know solubility rules?
I do, teacher. Yes, I do.
Amera, tell us the solubility rule on chlorides.
All chlorides are soluble in water.
Except there are two chlorides which do not dissolve in water.
Except lead to chloride and
What?
silver. Except lead to chloride and silver chloride.
Wonderful. Thank you. Thank you so much. Bate, can you tell us the solubility rule on sulfates? Bate, are you sleeping?
No.
Tell us the solubility rule on sulfates. Okay, let me help you like this. All sulfates are soluble, except, can you tell me the two sulfates that do not dissolve in water?
No, potassium and ammonia.
You're already offside. We said from the start, every potassium salt, sodium salt, ammonium salt dissolves in water. Every potassium, ammonium, and sodium salt is soluble in water. So Bate has just let us down, but let us continue. What is the definition of solubility? We said solubility of a salt is the amount of solute in grams required to saturate 100 grams of solvent, and the solvent is water. I'm going to give you one calculation in the test. There will be one calculation on solubility at least. But it will be very simple, so you'll pass it. So solubility is the amount of solute required to saturate 100 grams of solvent. And the solvent is usually water. And you must complete the definition by saying at a particular temperature. Why? Because solubility changes with temperature. So solubility of a salt is the amount of solute in grams required to saturate 100 grams of water at a particular temperature. Please, this time I don't want anyone failing the test. You have today, you have tomorrow. The test is only on salts, from salts up to where we stopped, up to preparation. Get your revision book where I even sent you the notes, summarize, and read this topic. Thank you. I know you'll pass it. So solubility is the amount of solute in grams required to saturate 100 grams of water at a particular temperature. We said a solute is described as soluble or insoluble. A soluble solute is a solute that dissolves in water, and an insoluble solute is a solute that does not dissolve in water. From there, we looked at these solubility rules. We said all ammonium. I'm repeating, please, you must never forget. Any solute that has ammonium is soluble in water. Any solute that has sodium is soluble in water. Any solute that has potassium is soluble in water. So all ammonium, sodium, and potassium salts are soluble in water. All nitrates are soluble. Anything that has nitrate, let it be potassium nitrate, ammonium nitrate, zinc nitrate, lead-2 nitrate, aluminium nitrate, anything that has nitrate, it will dissolve in water. That's solubility rule number 2. Chlorides. All chlorides are soluble except 2. Thank you, Amera. She remembers very well. Very bright girl. All chlorides are soluble except 2. That is lead-2 chloride. It does not dissolve in water. And silver chloride does not dissolve in water. But lead-2 chloride, we said it dissolves in hot water. Lead-2 chloride dissolves in hot water. I'm ignoring mercury because at your level there are no reactions of mercury. That's why I'm not mentioning it. For you, put in your head the ones I'm telling you. We say, but keep in mind that lead-2 chloride, it will dissolve in hot water or on heating. All sulfates, this is the one Bate does not know. All sulfates, anything that has a sulfate dissolves in water except, that word except should be in bold, except lead-2 sulfate and barium sulfate. And you see, if you don't know these solubility rules, you are not going to pass the other question of preparation of salts. Because salts are prepared depending on whether they are soluble or insoluble. So the whole chemistry is actually not only preparation of salts. In senior 3, in senior 4, all chemistry rotates here. Even in practicals, this is where chemistry lies. If you don't know this, you are going to be a very bad chemist. I'm telling you. You will not be a good chemist. Maybe a traditional chemist. And there I mean which doctor? They are the ones who are chemists, but they don't know the solubility rules. I don't want that one for you. So lead-2 sulfate and barium sulfate, they are insoluble in water. But calcium sulfate is sparingly soluble. Sparingly soluble means part of it dissolves and the other part does not dissolve. So it does not dissolve completely. But lead-2 sulfate, barium sulfate, they don't dissolve at all. All carbonates are insoluble except the other ones of group 1, because we said all sodium, potassium, aluminium, ammonia, all sodium, potassium, ammonium, they are soluble in water. So all carbonates are insoluble. And that brings you back to the other question I had asked you to prepare lead-2 carbonate. And many people were just writing nonsense. Lead-2 carbonate is insoluble. Was it lead-2 carbonate? I think lead-2 carbonate is insoluble in water. So it should be prepared by double decomposition or precipitation. Yes. Determination of solubility. This experiment, I will leave you to go through it, but you remember the procedures. We only need mass of the solvent and mass of the solute. Then we can complete the calculation. So I will just take you through the example here, which is the calculation. And it will help you to remember. In the calculation, we are saying 30 grams of sodium chloride crystals were dissolved in 75 grams of water at 80 degrees centigrade. Let me tell you, the moment you know the mass of the solvent and the mass of the solute, you have finished. There is no other chemistry there. The moment you know the mass of the solvent and the mass of the solute, you are done. Because what is the definition of solubility? It is the amount of solute in grams required to saturate 100 grams of the solvent. So if they have given you the mass of the solvent, it means this 75 grams dissolve 30 grams of sodium chloride. But from solubility, you should use 100 grams of solvent. So if 75 grams of water dissolve 30 grams of sodium chloride, then what about 100? That is how it goes. So we just say 75 grams of water dissolve 30 grams of sodium chloride. 75 grams of water dissolve 30 grams of sodium chloride. Then what about 1 gram? We divide by 75 both sides. By 75 here, by 75 there. 1 gram dissolves 30 out of 75. Then 100 grams will dissolve 30 out of 75 times 100. In other words, you are multiplying by 100 here, by 100 there, and you get the answer as 40. Meaning, if 75 dissolve 30, then 100 grams will dissolve 40, and therefore 40 is the solubility of sodium chloride. Who has a question here before I continue? Who cannot calculate this small thing? Who has a problem anywhere here? Feel free, but save time. That means it is okay. What a bright class this morning. That's why I like you. I have another example, but in this example, we did it also, it is in your book. Here they are saying 12 grams of potassium chlorate was carefully evaporated to dryness. So 12 grams of potassium chlorate was carefully evaporated to dryness. What do they mean by evaporation? Removing water. 2.4 grams of potassium chlorate were left in the evaporating dish. So when water was removed, so this is the solution containing water. This is the solution. 12 grams of potassium chlorate was carefully evaporated. So this is the solution. And when it was evaporated, 2.4 grams of the salt remained. Now I can ask, Maria, what is the mass of water that was evaporated? In other words, water which is the solute. Maria, 12 grams of potassium chlorate was carefully evaporated. Evaporated means to remove water. And 2.4 grams is what remained. So you had a solution containing water, you heated it, evaporated off the water, and you remained with 2.4. So what mass of solute remained? I mean, this is the mass of the solute, by the way, that remained. Solute or solute. So here, you first get the mass of water, and the mass of water will be the mass of the solution, which is 12, and you subtract the mass of the solute that remained. So mass of the solvent, which is water, will be mass of the solution, which is 12, minus 2.4, and that gives us 9.6 grams of the solvent. So The mass of water is now 9.6 and the mass of the solute is 2.4, and we want the solubility. So 9.6 grams of water dissolve 2.4 grams of potassium chlorate. That means 1 gram of solvent. That means 1 gram of solvent, which is water. I have divided by 9.6 both sides, 9.6. So 1 gram will dissolve 2.4 out of 9.6, and 100 grams will dissolve 2.4 out of 9.6 times 100. You multiply by 100 both sides, and there you get the answer as 25, meaning the solubility is 25. Now, is there anyone having a question on this part, please? I told you to feel free to ask even when I'm still talking. Ask a question where you don't understand, and I will guide you. Now, in this 75 of a saturated solution, this is again solution, and it contains 30 grams of salt. So to get the mass of water alone, first get the mass of the solvent, which is water. A solution means it contains both the solvent and the solute. So first get the mass of the solvent, which is 75 minus 30. And you go through the same procedure. That one is also very simple. Then factors that determine the solubility, we have amount of solute, we have nature of the solvent, the amount of solvent, nature of the solvent, and temperature. Those ones I remember explaining them even. Solubility curve, that one is also simple. I think you know how to plot. And I taught you, maybe I tell you, I remind you of the other thing. When they ask for the mass of crystals, mass of crystals deposited, remember, we get solubility at a higher temperature, then we subtract solubility at a lower temperature. For example, if on the graph, a solute P has a solubility of 180 grams at 90 degrees centigrade, and it cools to 30 degrees centigrade, where its solubility is 25. The mass of crystals deposited will be the solubility at a higher temperature, which will be solubility at 90, and it is 180. Subtract solubility at 25. We subtract solubility at 30, which is 25. Now, in the 10 minutes remaining, I want to go through preparation of salts. Remember the question that I asked you. The method that, example of salt that can be prepared by direct synthesis. The answer I wanted there, I told you the most favorable salt for that method is iron 3 chloride. So make correction. Go to your questions now. The most favorable salt for using direct synthesis or direct combination is iron 3 chloride. Neutralization, we said we use neutralization for salts whose oxides, carbonates, and hydroxides are soluble. Where the hydroxides, oxides, and carbonates are soluble. And those salts are group 1 salts. That is sodium, potassium, and ammonium. So salts of sodium, potassium, and ammonium, those salts are prepared by neutralization. Take note of that. Salts of potassium, sodium, ammonium, they are prepared by neutralization because their carbonates, their oxides, and their hydroxides are soluble in water. Then crystallization, all the other salts that are soluble in water, they are prepared by crystallization. For example, zinc sulfate, zinc chloride, zinc nitrate, copper 2 nitrate. They are prepared by crystallization. Then all the insoluble salts, they are prepared by double decomposition or precipitation. Example, the example that I had given you, lead 2 nitrate. Lead 2 carbonate, sorry. However, most of you were using carbonic acid, and I rejected that because carbonic acid is a weak acid. It may not give us enough carbonate ions. So I was advising you, remember, for double decomposition or precipitation, you use 2 salts, you react 2 salts together, but those 2 salts must be soluble in water. I was advising you to use lead 2 nitrate and sodium carbonate. So make correction. Instead of using carbonic acid, use lead 2 nitrate, which is soluble, and sodium carbonate or potassium carbonate. You get that? Or ammonium carbonate. So preparation of salts, having known how to use the methods, the general method is here. But first of all, most importantly, learn how to get the substances that must be reacted together. That is very important. If you fail to get the substances that are going to be reacted together to form the salt, you are going to get 0 on that part. So choose the substances that should be reacted together properly. So the general methods are here. For crystallization, we can use a metal. We can use metal oxide, and we can use hydroxide. But we usually use metal and metal hydroxide. But be careful, we may tell you what to use. For example, there is one time when I told you to use zinc oxide, and many people were using zinc. There you also get 0. If the question has said, prepare zinc nitrate from zinc oxide, and for you appear to be using zinc, you are still going to get 0. So always read the question properly. So preparation of salts from metals and dilute acid. Now here I said, if you want to prepare zinc sulfate, for example, then the metal you are going to use is zinc. But the acid should be sulfuric acid, which contains a sulfate. Don't prepare zinc sulfate using hydrochloric acid. Will you get zinc chloride when you are using hydrochloric acid? The answer is no. So for example, zinc sulfate, you must use sulfuric acid. Then you add, first pour sulfuric acid, then you add zinc powder to the hot acid little by little while stirring until it cannot dissolve anymore, and that is excess. Then you filter off the zinc oxide, and you remain with the filtrate. Then you saturate the filtration by evaporation or heating in an evaporating dish, and then allow it to cool. Allow the saturated solution to cool, and when it cools, it forms crystals. Then wash those crystals. First filter those crystals and wash them with distilled water. I told you, when we ask you a question about preparation of salts, 1.5 marks are for the equation. If you don't write the equation, you know that you have lost 1.5 marks. So preparation from metal oxides. For example, if you want to prepare copper 2 sulfate, then you add copper 2 oxide to sulfuric acid, because sulfuric acid is the one that contains the sulfate. Sulfuric acid is the one that contains the sulfate. So you are going to have sulfuric acid plus copper 2 oxide, and which gives you copper sulfate. What changes is that where there has been zinc, we are putting there copper 2 oxide. So the rest of the procedure remains the same. So learn the general procedure. Preparation of salts from insoluble metal carbonates. Here, still there is nothing that changes. For example, if you want lead 2 nitrate, we may tell you to add from lead 2 carbonate. That means you will be adding nitric acid to lead 2 carbonate because you want lead 2 nitrate. The acid to use is nitric what? Acid. So all soluble salts, they are prepared from acids. So choose the acid properly. And the equation is here. Maybe something small. Preparation of insoluble salts, probably. Preparation of insoluble salts. Now, I want, like the salt that I had told you to prepare, it was lead 2 carbonate. So, in that salt of lead 2 carbonate, you were supposed to use lead 2 nitrate, and instead of using sulfuric acid, you use another soluble salt, but which contains a carbonate. And the easiest one to use is sodium carbonate. So when you react lead 2 nitrate plus sodium carbonate, you will form lead 2 carbonate and sodium nitrate. So they will exchange the radicals. Lead will take the one for sodium and it will form lead 2 carbonate and sodium nitrate. So here you just need to know what to use. Even when you are preparing lead 2 sulfate, you can use lead 2 nitrate and sodium sulfate. Use 2 soluble salts. The two salts you use must be soluble. And they react together to form an insoluble one. And you must also learn how to write the equation. Direct synthesis, I said we only use iron free chloride. So I want to send you back to do corrections of the other assignment I gave you and send it. Today I will allow you to send inbox in my inbox of WhatsApp. Any question that you have about salts, send a question inbox and I will answer you. But send it after reading. So let us end here for now. I'm going to send a recording